All right, good afternoon and welcome to this week's Iowa Learning Farms Conservation webinar. I'm Matt Helmers at Iowa State University, Director of the Iowa Nutrient Research Center and faculty participant with the Iowa Learning Farms. And I have the great pleasure of getting to moderate the webinar again today. Glad to be back and helping to moderate. And it's a real pleasure today to introduce our speaker, Dr. Eileen Kladivko, that's a professor of agronomy at Purdue University. And Eileen's going to talk about drainage for the long haul, impacts on crop yield, soil health, and water quality. Eileen and I have worked together, I guess, about since the time I started at Iowa State 20 years ago. And we're involved with some projects where boy, it seemed like every week we were on a call, but maybe it was every other week we were on a call, or every few weeks. And now we've not been collaborating for a couple years as close, so have not got to interact as much. So I'm really looking forward to hearing from my friend, I think I can say friend, Eileen, about some of her long-term drainage work. And I think she's really looked at this from a comprehensive perspective, not only from the crop yields, but the water quality, and then, what really I think brings some of this that some of the rest of us haven't done on that soil health aspect. So with that, I'll turn it over to Dr. Kladivko. And as always, if you have questions, feel free to type those in the chat box, and we'll get those to Eileen when she's done with her talk. And with that, Eileen, the virtual floor is all yours.
Okay, thank you very much, Matt. And yes, I first got to know Matt when he was still a really young guy. Now he's just somewhat young. So anyway, yes, we had a great time collaborating on several projects. And so today I'm going to talk about drainage, a long-term drainage project that I've been involved with, which is why I kind of titled it Drainage for the Long Haul. And I will briefly touch on results related to crop yields and soil health and water quality. So as you all know, if you live in Iowa or anywhere in the Midwest, when we have naturally poorly drained soils, it really gives us many challenges for crop production. And this is certainly a scene that we don't like to see, our soybeans drowning out because we've got wet spots in the field. And so our solution, our first solution in many cases, is to install subsurface tile drainage. And that's really our first step in being able to improve crop production throughout much of the Midwest. So I'm going to tell you what we found first, and then I'll go into many of the details of that to support what I'm saying, and then kind of summarize at the end. So the first thing is that drainage pays if you have a naturally poorly drained soil. One of the things that it does is it improves timeliness of field work, and I'll talk about some details there. It improves crop yields. It improves not only our cash crop, but it also improves other crops that we might grow, like cover crops. It enables other conservation practices to work better to improve soils. So other things that we might do to improve our soil health, drainage allows it to work better. And overall, drainage is a long-term investment, right? So we're not putting drainage in and expecting that we're going to get a payback necessarily in the first year or two, but we know that over the long term, we have some benefits. So I'm going to talk primarily about a long-term project that I've been involved with, but the results and the learnings that we have from that really apply much more broadly across the wet landscapes of the Midwest. So this research was conducted in southeastern Indiana at the Southeast Purdue Ag Center, CPAC. And this was a part of the state that was not traditionally tile drained because of the nature of the soils. The soils were high silt, very poorly structured. They would kind of melt together. The old clay tile, they would silt in those old clay tiles, and or the water didn't get to the tile fast enough for the tile to really help. So with the advent of modern plastic perforated tubing in the 60s and 70s, the farmers in that part of the state were asking Purdue to do some research on this modern plastic tile system. And so that's where I came into the picture. I began at Purdue in 1982. The money from the state legislature was allocated in 1982, which had nothing to do with me being there, but my three senior colleagues, two ag engineers and one soil conservationist, had been working on trying to get that funding. So when I got there, I got the chance to work with these three very seasoned professors, and I was the newbie who knew nothing about tile drainage. So that project, what were the goals originally? Well, first of all, just to see whether drainage would work on the soil where it had not been used. This low organic matter, poorly structured, naturally poorly drained soil, would drainage tile actually improve drainage? Would it work? Could we improve soil physical properties because it was a very crusting and erodible soil? Could we improve on that? Could we increase infiltration and permeability? And could we improve crop growth and yield? The design of the experiment, just so you understand some of the results that I show in a little bit, the drains were installed at 4 different tile drain spacings because my ag engineering colleague wanted to know, well, what would be the optimum spacing be, provided that it works. So we wanted to look at the spacing effect on crop yield. The spacings were 5, 10, 20, and 40 meters. My senior colleagues all told me that for that soil, 40 meters or 132 feet apart was basically like the soil wasn't drained at all. The soil was so slowly permeable that that would be our control, essentially no drainage. The drains were installed at 2.5 to 3 foot depth, which is a little shallower than many of your drains in Iowa. In Indiana and Ohio, the drains tend to be a little shallower because of the nature of our soils and where the restricting layer is. And we installed the standard 4-inch plastic drain tube. In spite of the fact that it's a highly silty soil, we did not put any sock or filter on it at the recommendation of our drainage contractor, who basically said, we're just going to put it in at a steeper grade. And that grade for the tile was 0.4%, which is steeper than what most drain tiles are put in at. And that would keep any silt that did get into the tile flushed out. So that's what we did. I have the topo lines here on this map, but basically the slope was less than 0.5% over this field. So 3 spacings that we really considered drainage and 1 spacing that we considered to be our undrained control. We installed these in the spring of 1983 with the standard equipment at the time. The laser guidance, our main drain was parallel to the state highway right there. And our laterals went up perpendicular into the field. You could see here that we were using a standard trenching wheel machine, putting those laterals up into the field. The laterals exited first into a metal culvert so that we could measure the flow and sample the water for chemicals. And then from that metal culvert, there was a little stub that went out to our main drain and took the water away. So that was our installation system. So let's take a look at some of the results. Drainage pays. Great. That's a good thing to know. How does it pay? Well, one of the ways it pays is by improving timeliness of field work. So before you even get to the point of yields, how did we measure that? Well, in the first 10 years of the 35 years of data that I'm going to show you, we actually worked the different drain spacings when the soil was ready. So during the first 10 years, our treatments were continuous corn and spring chisel tillage. That was the standard tillage system in that area at that time. So we would go out, the farm superintendent and myself, we would go out and we would look at a plot, and if the narrowest spacing was ready to chisel, they went ahead and did it. If the next wider spacing wasn't quite ready, they'd wait a day and then the next day go out and decide, was that one ready or not? And so basically it proceeded that way with each of the 4 spacings being done when they were ready. So what that means, of course, is that some years, the first 2 or 3 spacings would be ready and then it would rain, right? And so then that would set the undrained control back to ground zero again. So over that 10 years, the undrained control plots were delayed somewhere between 1 and 15 days compared to the narrowest drain spacing. Some years, of course, it was real dry. Once it started to dry out, there was hardly any delay. So that was only 1 day later. But in 2 of the years, we basically were delayed about 2 weeks because rain would come in just about the time that plot got ready. It would rain again. So obviously a 15-day delay for most farmers who have more than one field, and one small field at that, would make a tremendous difference in their ability to get their spring work done. So that's going to be a major benefit for most farming operations, much more so even than our operation. And just as an illustration of the fact that the drainage did work, right, which was our first question, will drainage actually drain? Will tile drains actually drain this field? This shows an aerial photo where they drew in the blue lines here are just drawn in for where the tiles were. And you can see the lighter color here, meaning the lighter colored soil, meaning that the soil had dried out. They're all concentrated where our tile drains were. Okay, but you can see this darker colored soil here, meaning that the soil was still wet, is in this area where there were no tile drains. So that's our undrained control and our undrained control. So this photo really illustrates very nicely how well drainage actually did effectively remove excess water from the field. All right, so let's get into some of the data. I'm going to be talking about 35 years, okay? So this is the first 10 years. And basically our crop yields varied from year to year. I'm not going to go through every year. I'm going to point out first the 10-year average from 84 to 93. All of these bars are arranged with the dark blue on the left being our narrowest spacing, the 5-meter spacing, and then progressively going to the 10 meter, the 20 meter, and then this light blue is our 40 meter or undrained control. On average, over the 10 years, there was a 10 bushel per acre difference between the narrowest spacing and the undrained control. I'll get back to that in a moment. You can see that in some years we had exactly the stair step that we would expect, the highest yield with the narrowest spacing, the lowest yield with the undrained control. Some years we had the middle 2 drain spacings have the highest yield. 7 of the 10 years, the undrained control had the lowest yield, and the undrained control never had the highest yield. So going back to the 10-year average, 10 bushel yield advantage to the narrowest spacing compared to the undrained control. Frankly, I was very disappointed as a young researcher that it was only 10 bushels over a 10-year, averaged over a 10-year period. But there were a couple of reasons for that. Number one is that we only actually had 2 years out of the 10 that were very wet. And of course, the wet years are where you really expect to see the drainage benefit. And the other thing was that field had good surface drainage, which I will get to in a moment. The yield differences later on were quite a bit more, and I will get to those. Another aspect of timeliness to consider, though, is not necessarily the timeliness of the first planting, but the timeliness of a replant if you end up needing to do that. So after the first 10 years, we did switch our management, and starting in 1994, we went to no-till corn soybean rotation. So because we were no-till, we no longer needed to wait until the top 6 to 8 inches was ready to till. We just needed to make sure the top inch or two was ready to plant. So we ended up planting all of the treatments on the same day for the convenience of the farm staff, and because the differences were fairly small at that point. So we planted them the same day, but of course, if it continued to be wet after planting, in the extreme, maybe we needed to replant, okay? And one example of that was 2017. If you look straight out here, you'll see some corn rows that are just kind of coming up. If you look at the rows that are heading out towards the woods there, whereas on either side, east and west of that main area, we've got corn that had been growing for several weeks. So this was the tiled areas, or the original planting of this whole field was May 16th. By June 2nd, it was clear that the undrained control wasn't going to make it, And so they replanted, and this picture was taken on June 12th. So you can see here that the timeliness of when we actually got this planted and succeeded was quite a bit delayed, even though the original planting was done at the same time. All right, I said that the corn yields later in the experiment were quite a bit different. So this was from a later part of the experiment. And you can see that we had a couple years, 2007 and 2011, where the yield differences among the 4 drain spacings were small, still there, but small. But all of these other years, you can see that our undrained control is much, much less in yield than any of our drain treatments, 50 bushels or more in some cases, okay? And this is because it was considerably wetter in those years. The years that don't have corn are because we had soybeans. We had a corn soybean or corn soybean rotation at this point. So these yield differences are huge, right? And it's certainly within the 35-year lifespan or 40-year lifespan of a drainage system. But the weather was different, and so it made a huge difference in our yields. So if we take the entire study period from 84 to 2017, we had about 24 years of corn during that time. The undrained control, the 40 meter here, 144 bushel per acre per year. All of the drain treatments were in the 160s, as high as 168 bushels per acre. So much more significant yield benefits from drainage in those latter years. This is kind of a busy graph, but this is basically showing the corn yields over the entire project period, the dots, and you can see these bumpy lines I'm just connecting the dots, but I want to draw your attention to the trend lines. So the dark blue and yellow trend lines there are the overall linear trend over that entire time period for the 5 meter and the 20 meter spacings. And those trend lines basically mirror what we've seen, in the Midwest in general, that corn yields have gone up 1.9 to 2 bushels per acre per year on average when you look at the trend. And they were right in line with that trend over that time period. However, you notice the light blue dashed line here, that's the undrained control, is flat. So over that 34-year period, there was no trend for increased yields, in spite of the fact that genetics and technology had given us that benefit, as we expect overall, had given us that where we had drainage, but it didn't give us any benefit where there was no drainage. So the point here is that if we're going to take advantage of improvements in genetics and technology and everything else, the first thing we need to do is make sure that we have adequate drainage, right? If we don't have adequate drainage, we're going to lose out on all those other technological and genetic type of improvements. At this site, we didn't have any significant improvement overall in soybean yields. You can see the 10-year, or excuse me, the overall average for all of the soybean years, which was about 12 years during that time period. There was no significant difference. Occasionally, we had a big difference in yield, like in 2018, with the undrained control being quite low, but other years the undrained control was higher. And so on average, over the lifetime of this project, we did not see a significant change in soybean yields. Michael Langenmeyer, a colleague in the Ag Econ department here at Purdue, did some economic analysis for me on this project. And in this case, he's comparing our 20 meter or 66-foot spacing to our undrained control. And this graph is of the average difference in, is the gross revenue. The average difference in gross revenue over the entire project period was $60 per acre. You can see that in the early part of the project where the yield differences were pretty small, there wasn't as much difference. But in this later part of the project, in the corn years is where you see the big difference. a big difference in gross revenue, and the net revenue was also similarly different. So again, over the 30 to 40 year lifespan of a tile drainage system, we expect that if you need drainage, right, if it's a naturally poorly drained soil, that it's going to be really beneficial economically. Well, what about surface drainage? My field has pretty good surface drainage. It only has, like I said, about a 0.5% slope, but it's a little bit more slope than many of the Claremont soils in that part of the state, as my local farmers are happy to remind me of. So we know that the importance of subsurface drainage might not be as dramatic on my field as it might be on theirs, simply because we have good surface drainage. And we can really see this from a different part of the field, the impact of tiles versus no tiles in a place on the field where there was less than ideal surface drainage. So this was, again, a different part of the field, but this part of the field in the foreground did not have tile drains. And that part of the field was planted 3 times and drowned out all 3 times, and they gave up basically. So nothing, no stubble to see that next winter because no corn had grown. In the background, you see where it was tile drained, and the first time they planted, they got a good stand, they got a good crop. So obviously for a farmer who has a field that's got, just little pockets, little depressions, little places where the water tends to pond, drainage, subsurface tile drainage is going to be much more significant even than what it was in our case. All right, so let's move a little bit beyond the cash crops. Let's look at cover crops. Drainage is basically going to improve cover crop growth. In the upper left, you can see, this is back in that spacing field again. You can see where we had a good stand of cereal rye. This was mid-May in a year where we were going to grow soybeans. So we let the cereal rye grow a little bit longer. And when we harvested that for biomass measurements, we had about 3,100 pounds of top growth per acre from that cereal rye. On the bottom right, you can see the untiled or the undrained control. We had a good stand of rye. So it wasn't that we didn't get a stand. We did have a stand, but it simply didn't grow very well because it was too wet. So we had less than 1/4 of the top growth that we had where we had drainage. So again, if you are going to plant cover crops, you're planting them for a reason, whether that be scavenging nitrate or improving soil health or whatever it is. So if you're going to take the time and effort and money to plant a cover crop, you obviously want it to grow, okay? So drainage is going to be important, again, on a poorly drained soil. Over the years, I made other measurements, both on this field and other fields as part of my other research on soil health and earthworms and so on. And so earthworm populations were generally higher where we had no-till versus chisel, where we had tiled versus untiled, where we had covers and rotations and manure and so on versus the control, and other soil physical properties that we would measure on different experiments also tended to be improved by cover crops and rotation, things like aggregates and stability and infiltration, but particularly where it was tiled and not so much where it wasn't tiled. And this is a picture from just a couple years ago where we were trying to look at some of the soil structural development with depth. And this was in our narrow drain spacing. And you can see all these nice dark lines here, which were basically from the night crawlers or the deep burrowing earthworms that were pretty prevalent in the drained treatment, but not very common at all in our undrained treatment. So before I move to the nitrate, I want to kind of summarize this part. Drainage enables other conservation practices to work better. So if you have a naturally poorly drained soil and you want to use conservation practices like no-till and cover crops and rotations with hay crops, those are all more effective in increasing crop yields as well as improving soil physical properties and soil health in a tiled field versus an untiled field. So I like to kind of remind people that adequate drainage is a necessary first step if you're trying to improve crop yields and soil health. Just doing good agronomic practices alone it's not likely to make up for an inadequate drainage system on naturally poorly drained soils. All right, I'm going to shift gears here for the last little portion of the talk and talk about water quality or nitrate leaching. This is a graph of the annual nitrate concentrations in milligrams per liter or parts per million. So on the vertical axis, we have parts per million over the 30-year period that we were doing these nitrate studies, and giving you just the short version. In the early part of the study, we had concentrations that were between 20 and 35 parts per million nitrate nitrogen, which is high, but which was typical for the time. We were growing continuous corn. We had high fertilizer nitrogen extension recommendations. We had no cover crop. We had chisel tillage. As time went on in this experiment, we changed practices. We reduced the nitrogen rate first because the extension recommendations did change from 250 to 200 pounds for continuous corn. And then after 10 years, we shifted to a corn-soybean rotation. Because we had soybeans in the rotation, we could now reduce the nitrogen further to 175. And we also started growing a cover crop. So after we did all of that, we basically had concentrations that were between 6 and 10 parts per million consistently for the remainder of the experiment. This red line is the 10 part per million drinking water standard. So we at least want to be below that, and we are. I can't, in this experiment, I can't separate out how much is due to the change in fertilizer rate and how much is due to the cover crop, but work in Iowa and in other states has clearly shown the cover crop, even by itself, will significantly reduce that nitrate concentration. All right, I have a series of 3 slides to translate this into loads or total loss. The first thing is looking at the effect of drain spacing itself, which was one of the main things we were testing in this project, right? So closer drain spacings, the reason that we put tiles closer and closer together is to get rid of more water faster. So if we get rid of more water faster, it means we also get rid of, we don't want to, but we get rid of more nitrate faster. Nitrate has nothing in the soil to hold it. And so if water's flowing, nitrate is flowing. All right, so in this early part of the experiment, the gold bar here is the 20-meter spacing. We lost, on average, 23 pounds of nitrogen per acre per year coming out the drain. As we brought those drains closer together, we lost more and more water, so we lost more and more nitrate. And in that narrowest spacing, we lost 44 pounds of nitrogen per acre per year. Pretty high? Pretty common. Iowa has Tom Casper and his colleagues have some similar numbers. All right, the good news is that when we did those things I talked about, changing our fertilizer rate and adding cover crops, we reduced those concentrations, as you saw in the first line graph, and that reduced the total amount that we lost. So now the 20-meter spacing was losing about 11 pounds of nitrogen per acre per year. We still had an increase as we brought those tiles closer together, but it was much reduced, okay? The not quite so good news is that even with that low concentration, the next period, the next 16 years here, we had we still had the same low concentration, but we had greater losses again. Not as great as what we had early on, but we had greater losses. Why? Because we had 5 inches more rain, most of which came in the winter and early spring. So most of that 5 inches ended up as additional drainage. So we had more water flowing through the soil. So whatever nitrate was still in the soil got carried away. I do want to say, I forgot to mention, but this fertilizer has always been applied in the spring or side dress. We've never applied it in the fall. So the fact that we lose nitrate in the winter and early spring is because maybe there was a little left over from the previous year, and because soil organic matter is constantly slowly mineralizing, and so nitrogen gets released and can be carried away. So this is the graph where I try to make my plea to folks that if we are intensifying drainage, and I know, I'm a proponent of drainage, we need it where we need it, and if people are putting tiles closer together than they were, intensifying drainage, then we also need to intensify our management of nitrogen. Otherwise, we're going in the wrong direction, right? We bring those tiles closer together, we lose more nitrogen. That's going opposite of what we need to be doing. So let me summarize. Drain spacing definitely matters. Hopefully that's been pretty clear from our data. Excess rainfall matters. Of course, we have no control over that, but if we get more rain during the period when we have drainage, we're going to lose more nitrate because we have the water to carry it away. Nitrogen fertilizer rate and form matter. I only briefly touched on that today. That's a whole nother talk. Cover crops reduce those nitrate concentrations and loads. So again, my plea is if we intensify drainage, then we also need to be intensifying management of some other aspects of the system, such as cover crops or such as controlled drainage water management, to basically reduce the leakiness of the system during that off season. All right, 2 concluding slides. Drainage is definitely a long-term investment. Drain flow itself develops over time. Yield effects, of course, are going to vary from year to year based on how wet or dry the year is. Conservation practices, such as cover crops and no-till and so on, take time to improve soil health. But that long-term improvement in cash crop yields and cover crop growth and effectiveness of those other conservation practices makes tile drains a good investment. So my concluding slide is if you want more details on any of this, I have both some short videos, so you could watch parts 1, 2, or 3, and or you could read the extension publications on those same 3 topics. Yields and times in one of them, cover crops and conservation practices is number 2, and the nitrate story in number 3. They changed the website address on me, of course, so the easiest way to find it now is just to Google Purdue CPAC drainage, and you'll be able to find it that way. So Matt, with that, I am done. Do you want me to advance to those other 3 slides right now?
Yep, let's do that. Thank you, Eileen. And if people have questions, feel free to type those in the chat box. After we go through these next couple slides, we'll get to that.
Oh,
I think it just
now how do I get that out of here?
I just closed that, just hit the X on those.
You know what happens is,
there we go.
Yeah, how do I get to the X on this one?
There we go. There we go. We got it. Okay. There we go. Okay. If you need
it gets hidden underneath the bar and I can't find it. Okay, there you go.
Okay. If you watch this webinar and you need to earn or would like to earn a CCA CEU, please send your name, the name you entered to watch the webinar, and your CCA number to Elena Whitaker, and her email is alenaw@iastate.edu. Again, alenaw@iastate.edu by 5 o'clock today. And I probably don't need to repeat that as much as I do because everybody that needs a CCA is familiar with how to do that. But by 5 o'clock today, email your name, the name you entered to watch the webinar, and your CCA number. We can go to the next slide. If you've watched this webinar live and are willing to fill out a voluntary demographics survey, you can go to that website, iowalearningfarms.org /survey, or you can scan the QR code. If you submitted one for a 2023 webinar, thank you very much, and you don't need to do it again. But if this is your first webinar and you might be willing to do that, that would be fabulous. Okay, let's go to the next slide. We're going to have Craig Clarkson with ISG talking next week on the webinar, looking at Market District Green Infrastructure, one of the largest urban water quality projects in the Midwest. So something a little bit different, but tune in next week for Craig Clarkson. And then I'm going to see if I can share my screen quickly. I just want to put in that tomorrow we're going to have a bit of a emergency webinar. Dr. Dan Anderson, that's here in our Department of Ag and Biosystems Engineering, is going to give a webinar on when wells run short, options for livestock farmers when water becomes an issue. We've we've gotten a couple questions on this here in the last couple weeks about concern in Iowa in some places about water supplies and water supplies for livestock. And so Dan's going to talk a little bit about that, revisiting some information a colleague of ours, Sean Schaus, put together a few years ago. So that will also be archived on the Iowa Learning Farms website. So if you miss it tomorrow, you can go back and watch it. But if you know of somebody that you think might be interested, please let them know that we're going to do it tomorrow at 12 o'clock. Same time, same place, just on Thursday, not Wednesday. Okay, with that, now we can go back. We'll go back to questions for you, Eileen. Sorry for all of that. So there was a question here. If there was, I don't think you did any irrigation on this site, but did you
No.
do any data on moisture stress in the different treatments?
Yeah, we did not do any irrigation, but I I have data on I have soil moisture data. So that's not been fully vetted, but basically, yes, it said in the dry years, obviously there was a big well, in all the years there was a difference in soil moisture content that goes along with what you would expect based on drain spacing, right? So the narrower spacing was drier, sometimes too dry, but most of the time, very good. And the undrained control was wetter to the point of being too wet.
Okay. The next one is on soil organic matter. Did it change over time, and would knowing it on a property potentially change the speaker's opinion on the benefits of drainage?
I didn't quite
Okay.
understand the last part of that, but
I guess the last part I think is, if you knew something about organic matter, would that change your opinion or view on the benefits that you would get from drainage?
Yeah. So we've actually measured organic matter a couple of times, and there was very little change. There's two parts to that, right? One is that when we took the samples, we were hypothesizing that the middle spacings would probably be the best, because if you have the narrower spacing, that means your organic matter is going to decompose faster because you have better aeration, you have less wet conditions, so organic matter might decline. However, with the narrower spacing, you also get better crop growth and better root development, which means you add more organic matter in. So we were hypothesizing what would be the best combination, right? If it's undrained, the organic matter doesn't decompose, but you don't get as much productivity in the first place. So we thought actually there might be a curve in there, and it might actually be best in the middle. As it turns out, we saw very, very little difference. And again, I was disappointed. I kind of expected to see more difference, but we did not. So it's a bit of a trade-off, right? You get greater productivity, and therefore you're putting more carbon into the system, and your microbial activity works better. Your cover crop growth is so much better. So you get a lot more input. And that apparently, at least here, has more than compensated for potentially faster decomposition with a little less wetness.
Okay. And maybe they're kind of along those lines, but they kind of fine-tuned the question here. Does having higher percent organic matter reduce the benefit of drainage, i.e. because the soil holds the moisture better?
Well, that's an interesting question. I think a higher organic matter soil would still need drainage in order to be most productive because of the aeration for the plant growth. I also think that, so like cover crops, even our cover crop recommendations, our cover crop selector tools will show that a poorly drained soil, a lot of your cover crops will simply not grow, or not grow very well at all, because it's too wet. whether it's high organic matter or low organic matter. So I think you still need drainage in order to get the productivity from whatever it is you're planting.
So I guess, did the economic analysis include the cost for the different tile spacings, and then kind of add on, what tile spacing do you recommend?
Yeah. So yes. The economic analysis did include all of the costs of putting the tiles in at those close spacings. And, I'd have to look at his analysis again to get all the gory details. But yes, no, he definitely included the cost of the tile and, how much more. And that's why the intermediate spacing comes out better, because the narrower spacing had a higher yield, but not enough higher yield to pay for all of the additional tiles that were installed there. So yeah, in the analysis that he did not try to find the exact number, right? He just used the spacings that we had, and the 66 foot came out to be the best. I would probably, the 33 didn't pay as much as the 66, or, the 10 meter didn't do as much as the 20 meter. I would probably go more like 50 foot. So somewhere in between those would be probably what I would recommend. Of course, there are people who are putting them in narrower than that, but I think the 50 foot is probably a pretty good compromise.
Okay. So I guess there's somebody that's kind of, kind of thinking about how we balance our conservation efforts, to protect or increase wetlands in maybe poorly drained area versus, thinking about that drainage pays. And so are there scenarios when some of these poorly drained areas may be better suited to be wetlands as opposed to row crop, and instead of tiling, considering precision conservation, perennial planting for water quality and habitat outcomes?
Sure.
Yep. Okay.
No, I mean, I think that's, and in Iowa, you have a lot more of the pothole topography than what we have here in Indiana. But certainly, there are going to be some areas that maybe are not worth tiling because it's too much. It's both from the economic standpoint and from the ecological standpoint. But that's a much broader question than what I was addressing.
Yeah.
In this research, but certainly I think that's worth looking at. Is one little wet hole worth tiling?
Yeah.
Or should it be as a wetland and have those other benefits? Then that becomes a practical issue. Can you farm around it? Is it worth draining it? Is it worth, from the ecology standpoint, would it actually help in that field ecologically to leave it alone, and maybe in some cases even get a rental payment from NRCS for doing something else? I think that, those are really interesting questions, much more complex than what we were looking at here. Yeah. If it's a field that's relatively uniform topography, that's poorly drained, then I think tile drainage is a clear winner. But if you've got these other areas in fields that are not really that productive and would be really helpful ecologically, then that seems like something to really consider.
Yep. Okay, great. And you might have mentioned this, and actually this person and I also didn't catch it. So if you mentioned it, I apologize. And I think this person would as well. Were the plots planted when they were all ready, or, like all on the same dates, or did you adjust planting based on the soil moisture conditions of those,
so the first, I know what you're saying. The first 10 years when we were doing chisel tillage, each plot was planted when it was ready. And so that's what gave us the timeliness benefits, right? The narrow spacing was ready on April 20th. The next one was ready the next day, April 21st, and then it rained. And then they started over, for the other plots. So the first 10 years when we were doing chisel tillage, each plot was done when it was ready. Once we switched to no-till, which was year 11, we then planted them all on the same day, mostly because, well, for two reasons: the convenience of the farm staff. This project was taking a tremendous amount of their time to go out every day and decide whether it was ready. And with no-till, you have a little bit more of a leniency there, right? Maybe the narrow spacing could have gone the day before, and the undrained maybe should have waited another half a day, but they're close enough because you're not tilling, right? So we did not have timeliness benefits in those later years. We did not assess timeliness benefits in those later years, but those first 10 years was where we had a big difference in timeliness.
So this one, interesting one. What has a bigger effect on nitrate leaching, drain spacing or cover crops? And could there be an interaction such that the difference in nitrate leaching between widest and narrowest spacing is much greater for no cover crops versus cover crops?
Yeah, both drain spacing and cover crop have a huge impact on nitrate loss. In our case, drain spacing had no effect on concentration, but cover crops did. Okay, so if you grow cover crops, you reduce the concentration, but we reduce the concentration equally on all of the spacings. The spacing is right. So load is two things, right? Load is concentration and water flow. So the cover crops reduce the concentration of all of them. The water flow is affected by the spacing. And there's a huge difference in water flow for us based on the spacing. So I can't really say which one is more important for load because it depends on the year. If it's a year that has a lot of drainage, then the drain spacing, well, the narrow drain spacing and no cover crop, you're going to lose a huge amount. The wide drain spacing and no cover crop, you'll lose less, but how much less is really dependent on the year. So I'm not sure that there's a synergistic effect there in the sense that the concentrations were the same across all the spacings. With no cover crop, they were high. With cover crop, they were low.
Probably the one thing I wonder with that wide spacing, if we got less cover crop growth, we might expect that to reduce the nitrate concentration less, right?
Yeah, if you got less growth. We didn't get, in most cases, the only one where we got a lot of difference in cover crop growth was the undrained control.
Okay. Yeah.
Yeah, there were a few years where the wider spacing had a little less growth than the narrow, but not very much different.
Okay. Yeah. Okay. There, I guess, kind of a question. I'm not sure that that this study really looked at it, but do tiles increase the total amount of water leaving a field, or do they just reduce the amount of surface runoff?
We never adequately really researched what happens to the rest of the water. That question that we keep getting, Matt, in our regional drainage group. We had a little more surface runoff. We did not measure it, but there was a little bit more, but I don't think the amount of difference on the surface runoff handles the difference that we had in the drainage. So I think we actually probably had more losses to deep seepage with the wider spacing, but we never adequately really researched that.
Yep. I think you mentioned it and I missed it. What remind me what your drain depth was?
Between 2.5 and 3 feet.
Okay, cool.
So a little shallow compared to, we don't call that shallow in Indiana. We call that normal. And Iowa,
right.
I know it's more like 4 feet.
Yeah, right. Yeah.
But it's because our restricting layers are shallower in Indiana in general. So.
All right. I think in the interest of time, we will kind of stop there. Eileen, thank you so much for the presentation today. I think it's really useful and really important to think about drainage going along with some of these other conservation practices like no-till and cover crops and so I think it's important to think about this as a system, and that's what you're able to do. Again, if somebody needs a CCA credit, email Elena Whitaker, ALENAW @iastate.edu by 5 o'clock today with your name, the name you entered to watch the webinar, and your CCA number. Highlight that there'll be another webinar next week talking about urban infrastructure, and tomorrow, emergency webinar from Dan Anderson talking about water for livestock, and if there are concerns about running short on water, feel free to tune in for that, or and let folks know if you have somebody that you think might be interested. With that, Eileen, I'll give you the last word.
Oh my gosh.
Yeah.
Adequate drainage, but don't overdo it.
Okay. All right. Oh.